Did you know lift, weight, drag, and thrust? Okay, I'll show you. So this is the lift and this is the weight, while this is the thrust and this is the drag. Now, lift is the opposite of weight and thrust is the opposite of drag. Simple as that. Next is the three-axis movement of an aircraft. This is called the roll axis and this is how it moves. And this is the pitch axis. And the last one is the yaw axis. Next up is the major components of an aircraft. First is the fuselage, or the central body of an aircraft, where we can find the cabin crew, captain, baggage, and of course, the passengers. Secondly is the wings. We all know what wings are for, right? Thirdly is the power plant, or the engine of an aircraft, like what you can see here. Fourth is the empennage, or the tail, which function is to control and stabilize the yaw and pitch of a UAV. Last is the landing gear, which is the principal support of an airplane when it is on the ground. We'll move up to the three different types of aircraft construction. First is the truss structure. Length of tubing called longerons are welded to form a well-braced framework. However, it lacks of streamline shape. Second is monocoque. It uses stress skin to support almost all loads. It is very strong but not highly tolerant to deformation of the surface. Third is semi-monocoque. It uses substructure which consists of bulkhead and formers of various sizes and stringers. Atmospheric pressure. Since atmospheric pressure at any altitude is due to the weight of air above it, pressure decreases with increase of altitude. Atmospheric density. The density of air has a significant effect on aircraft's performance because as it becomes less dense, it reduces first power because the engine takes in air. Second is thrust because the propeller is less efficient in thin air. Lastly, it reduces lift because thin air exerts less force on the airfoils. Lift. What truly produces a lift in an aircraft for it to go up? In this part of the video, we will take a look at the theories as to why an aircraft is able to go up to the skies. Newton's first law of motion. An aircraft at rest will remain at rest unless there's a force strong enough to keep it moving. Newton's second law of motion. It covers both changes in direction and speed, including starting up from rest and coming to a stop. Newton's third law of motion. The propeller moves and pushes back the air. Consequently, the air pushes the propeller for it to generate lift. Bernoulli's principle. Velocity of fluid increases while the pressure within the fluid decreases. As the wings move through the air, the flow of air in the curved top surface increases in velocity, creating a low pressure area. Thus, the airplane wings generates lift. Anyways, we have here the airfoil design. This is the airfoil. Airfoils are designed to produce a lot of lift and minimize drag. They are usually found in airplane wings, but they can also be seen in wind turbine blade or propellers. They are also used in cars. They come from different sizes and shapes too, depending on the aircraft's use. For the simpler understanding, the lift is caused by the pressure distribution around the airfoil. Here's a little information about the history of flight. Do you not know Leonardo da Vinci? Ah, yes. He's the famous painter, but not only a painter. He is also one of those who contributed to the history of flight because in his notebook, there's bird-like wings like this. And the famous Wright brothers who invented, built, and fly the world's first ever successful motor-operated airplane. And that's it for the that's it for the video. I hope I shared everything I've learned in my bridging subject Introduction to Aviation. It was a fun experience and a little bit stressing, of course, to be able to learn more about aviation. That is all. Thank you.